Okay, so we're going to start from the beginning, and the first problem is basically a multiplication problem. They just wanted to see if you could multiply a big number by another big number. Notice I had to really make sure that I was looking at where I was doing my carrying and when I was regrouping, and I tried really hard to make sure that I was lining things up. And it's hard when things start to slant over, so you have to be very, very careful, and I got this one. Alright, let's start with the second one. Bakari buys 3 toys that cost $8.72 each. What is the total price? So at first I know it looks like when I was breaking this up into 3, but when they asked me what is the total price for the 3 toys, I realized, oh, they're not telling me to break it up. They're telling me to find out how much all 3 would be together. So you really have to make sure you're being careful with words like each, because sometimes it can mean division, but sometimes multiplication. And in this case, it is multiplication. So 6. 21, 24 plus 2, 26. Since my decimal is 2 places over, I have 2 numbers behind the decimal. The same thing has to happen here. $26.16. And there it is, $26.16. A building is being constructed 45 yards high, 25 yards wide, and 10 yards long. So let me get all that information. That's how high it is, that's how wide, that's how long. So I already know it's going to be a volume problem. If the height is increased 60 yards, how much will the volume increase? So I'm going to draw it. It's 45 high, 25 by 10. My bottom doesn't really bother me that much. And I'm going to imagine I just find out volume for this. So 45 times 25. Carry the 2, 10, carry the 1, 9. So already I have 1125 times, and I have to do times 10. I already know that just means I'm just going to put a 0 behind it, because I know how to multiply by 10 really well, just adding a 0. But they're asking me what if it's increased 60 yards. So that means I'm going to imagine that this building is 60 yards higher if I added more. So let's think about what that would be. So now I have 105 times 25. 25, 5 times 1 is 5, 2 times 5 is 10, 2, 5, 2, 5, 2, and I'm going to multiply this number by 10 again. So I know this is the new volume. So they're asking me how much bigger it is. So I'm going to take this number and I'm going to subtract our other number. Okay, I'm going to need a little bit of space for that. So I'm going to move it over here. So I had 25 to 50, which is if it was bigger, minus 11 to 50. And I get 1,400. Did I subtract something? Oh, I see my error. See, when you don't see your number, you probably made an error somewhere. So when I go back to my work, I find my error really quickly. When I added, I forgot to add here. That this should have been a 6. So anytime you don't see your choice, it doesn't mean that the book is wrong. It means you made a calculation error. So I'm glad I made that mistake. So let me go back to my subtraction. This was actually a 6. And now when I said, I know that this is supposed to be 1,500. Here it is. So when you don't see your answer there, just double check your work. Okay, let's go down to this one. Keon is drawing a quadrilateral, so I know it's 4 sides, with at least 1 set of parallel lines. That means it could be 1 parallel lines, it could be 2. So what could be the list of all the things? So if it has at least 1, it could be a trapezoid. If it has 2, it could be a rhombus, it could be a square, it could be a rectangle. It cannot be a kite because a kite doesn't have parallel lines. Anything else it could be that I'm forgetting? It could be a parallelogram. So it could be any of those things, any of those 5. So let's see. It's true, it could be all these. But I named a lot of them. I named 5. This one added a rhombus because it could be a rhombus. This one added the trapezoid just in case it has at least one. And this one has all 5 that I've named, so I'm going to choose that one. That was tricky and just in the way it was worded. Okay. Which number is equivalent to the following? 6 divided by 10 to the second power. So that's the same thing as 6 being divided by 100. That means I'm going to think about the number 6, and it's going to get smaller. I'm going to move the decimal 2 times. And then because it's smaller, I'm going to go this way because I want it to get tinier. 1, 2. So it should be 600. Sometimes they'll write it like this, so don't get tricked about that. That's really, really silly. And boom, there it is, nice and easy. Okay, Grayson's father bought 9 sweaters at the store. The cost after tax was $293.52. If each sweater was the same price, how much did he pay for each sweater after tax? Round to the nearest cent. So I know I'm going to go to the nearest hundreds place because they said round to the nearest cent. So this is a division problem. He bought 9 sweaters. I'm going to think about my place value. 9 cannot go into 2. Goes into 27 3 times. Goes into this number twice. A decimal just goes right up. Bring down my 5. 9 goes into this number 6 times. That's 54. 2. 9 goes into 12 1 time. Oh, it's spilling down to my next problem. That's okay. And even though I have a remainder, it said round to nearest cent, so I'm going to bring down another 0 just in case. And 9 goes into this number 3 times. So I'm going to round to nearest cent. It's still going to be 61 cents. $32.61. I just wanted to see if I was going to have to round up or down. And here it is, $9.61. And you see, just in case they had to round up, it was going to be there too. All right, let's go down to the bottom one. 5 friends are sharing 2 trays of apple cobbler. How much of the 2 trays of cobbler will each person get? So it's 5 friends are sharing 2 trays. So it's the 2 trays are being divided by the 5 friends. I could also write that as 2 trays being divided by 5 friends. I could write it this way. Just in case, let's actually figure out what that problem is. The 2 is being divided by 5. I know it's going to be a decimal, so it cannot go in there. And I like to round to the hundredths place. 5 goes into 24 times. And there's 0, so it should be there. It should be, if it was a decimal, it would be 40 hundredths. So let's see what we have here. Oh, they just wanted to see it as a fraction. And look right here, 2 divided by 5. 2 divided by 5. Didn't even need to do all that work. But it's okay because I'm pretty sure of myself. Okay. This type of problem is just asking you to figure out the expression for the part that overlaps. So this is the part that overlaps, meaning both of them covering. So what do I see? On the top part, I see 1/3 is shaded. On the sides, I can't look here on the sides because it looks like all of them are shaded, but they want to see just the red. So how many on the side are shaded? 2/5. Just 2 out of 5. So that means my problem is 1/3 times 2/5. That's the expression I see. And I will get 2 out of 15. And this is true. Only 2 are shaded out of 15. Let's look at my choices. And there it is. 1/3 times 2/5. Okay, let's look at the bottom one. It's a volume problem. We're trying to figure out what is the volume of this rectangular prism. Sorry, my hand is starting to shake from holding the iPad up. So I see 3 units here. 1, 2, 3, 4, 5. 5 units here. And 1, 2, 3, 4, 4 units here. So 3 times 5 times 4. 15 times 4, and that equals 60. That's all. There it is, 60 cubic units. This one's going a little bit faster. We have one more to do. Okay, a grocery store charges $2 for a jar of peanut butter, $4 for a loaf of bread. Each jar of peanut butter and loaf of bread bought together, the store will subtract $1 from the price. If she purchases 4 peanut butters and 4 loaves of bread, what expression could be used for the total price? Okay, so they charge 2 for the peanut butter, and 4 for the bread. And we want to know, and every single time they buy it together, they'll subtract $1. So if he does 4 jars of peanut butter and 4 loaves of bread, how much is it going to cost? Okay, there are lots of different ways I can put this problem together. I could think of it as, let's think about how much the peanut butter is going to be. 2 times 4, because he buys 4, plus 4 times 4, because that's going to equal the bread. And I'm going to subtract, how many times do they buy it together? 4 times. 4 times $1. So I could think of it this way. So let's see what they have so far. And just looking at the work, I can see, let's see what they have here. They're doing 4 times. They're adding the peanut butter and the bread and subtracting $1. That makes sense because they're doing this 4 times. So you're getting 6. They're adding it together. Minus $1 makes it 5, and you're going to do that 4 times. That makes a lot of sense. Here, again, they're multiplying the bread and the peanut butter. That does not make sense because we can't multiply the peanut butter and the bread. So in this one, you have to kind of look at the numbers. Here, we have 4 times $1. That makes sense. 4 times the peanut butter and 4 times the bread, but they're adding it all together. I know that's not true because we're subtracting this price, so that cannot make sense. And 4 times $4 plus 4 times $2 minus only $1. But they said they're going to subtract $1 each time. So that cannot make sense either. So it has to be A. So even though it didn't look like my answer, I had to look at it more carefully. And it did make sense. They wanted you guys to add up the prices together first and then take away the $1.